All right, so I want to go through and take a look now at the motion-related problems on this practice test. So, again, I'm going in the order of the study guide rather than the order of the problems here, so I hope this is helpful. So a tennis ball is released from rest and falls vertically through a small distance in the air. So this is something we got to get memorized for air resistance. So when we have air resistance, the velocity versus time graph looks like this. We start from rest, and then we get faster and faster and faster, but the rate at which we get faster and faster levels off until we reach terminal speed. So our speed increases the whole time. Now for the acceleration, it starts off as being equal to g, and then it kind of decays in time as the drag force approaches the weight in value. They cancel. So the speed of the ball increases, the acceleration of the ball decreases, and so we get choice A as our answer. Now for choice B, we have the velocity of a car traveling in a straight line, and we wonder what the displacement looks like. So this is one of those things where we got to really get our graphs carefully learned. So if we have displacement versus time, or displacement against time, first we start off with a we're going at a steady pace in a straight line, so we have a nice linear graph for position versus time, again moving forward at a steady pace. Then we move forward slowing down, so that means our slope needs to get flatter and flatter as we continue. So choice C really is the only choice that works. Now, if they'd asked us, coincidentally, if they'd asked us for the acceleration versus time, that would actually be this graph right here. This would actually be acceleration versus time, in case you were wondering. Okay. So, that's problem number 4, continuing on. These are force problems. We'll get to those later. More force problems. Just to be clear, 10, 11, and 12 are topics we actually haven't covered yet, so we're going to skip those until next semester. We've done these problems, 13 and 14, been done already. Now here we show the velocity versus time for this truck, and we want to know what can be deduced. So let's be clear. The slope of this graph gives the acceleration. Now, when we get the slope, what we actually do is we plant a point here, we grab a ruler, and we actually draw the tangent line. And if we do that at any point along this graph, what we realize is that A is never 0. Okay? So A is not equal to 0. It's always, so A is never equal to 0 on this graph. So that's one thing that we can always say. So we know the truck is always accelerating. Is the truck always moving? Well, right here, V equals 0, so that's false. Is the truck always moving in one direction? So it's moving forward here, and it's moving backwards here. This is negative velocity, so that means backwards. So that's not true. Now the displacement, that's the area under the graph. And when I look at this graph here from 0 to the end here, this area here is clearly bigger than this area. And remember, the area under the V graph gives us the displacement. And clearly this area is bigger than that, so we don't have 0 area. So that means choice A is always, choice A is the right choice. Now for here, 17 we'll get to later, 18 we're skipping, 21. Air resistance acts on the object we went under the graph of acceleration versus time. Please memorize this, that this is D. And remember that if we have air resistance, that value at the beginning should be G, the acceleration due to gravity. For an object to be translational equilibrium, we'll get to that when we deal with forces. Now here, we have an object that has displacement versus time. So moving forward with moving with negative acceleration, let's be clear here. These don't work because it's clearly just no acceleration. So A is 0 here and here, because displacement versus time is a straight line graph, which means we're moving at a steady speed. Now here, we're going from slow to fast, and we're moving forward. So it's not just that we're speeding up, it's that we're speeding up in a positive direction. So this is actually positive acceleration. This here is negative acceleration. Yes, we're moving forward, but we're slowing down. So A is backwards or negative. That's the idea. All right. Let's see what else we got. These are force questions. We'll skip those. Let's see. This one. We have a particle accelerating from rest, and we want to know what the speed of the particle is at 6 seconds. So let's just measure it off here. Again, if we have acceleration versus time, the area is the change in speed, or change in velocity, sorry. And since v initial is 0, we know that this is just if u is 0, then the area, sorry, it's writing slow, is v. So we'll get the area as 1/2 base times height, because it's a triangle. Well, the base is 6, the height is 3, so that's going to be 1/2 times the base, which is 3, times the height, which is 6. That's 1/2 times 3 times 6, 1/2 of 18. That's going to be 9.0 meters seconds to the -1. Let me just add these decimals here to make it complete. So that is question number 3 on the extended questions, or the extra questions. I just didn't number them properly. Sorry about that. And that pretty much covers all of our motion questions.